So we discussed last time that heat transfer can be mainly of three modes: conduction, convection, and radiation. We talked about conduction, that mainly it's undergoing through a solid. Also, it can be through fluids and gases, but it's dominant in solids. For convection, we have a fluid in contact with a surface, and we talked about several types of convection, like natural or forced. And we were talking about radiation. So for radiation, the main characteristics are the following. You have that heat is exchanged between surfaces. You have surfaces and they are at different temperatures. So let's say you have T1 and T2. And what is exceptional for radiation is that you don't need a medium for propagation. Conduction and convection need a medium for propagation of heat. However, heat in radiation form will take place just through electromagnetic waves, and it does not require a medium. This is why, for example, it's enough to have two surfaces of different temperature. Even if you have an empty space between them, you still have exchange of energy between them. And we can say that the rate of radiation from a surface, Q radiation, it can be shown that it's equal to epsilon times sigma times area times temperature to the power 4. Epsilon is called the emissivity of the surface, and it's a characteristic of the surface that is varying from 0 to 1. If we say that the surface will behave like a black body, whenever you say that the surface is like a black body, this means that it's a perfect radiator. So epsilon will be 1. So epsilon is 1 for a black body. And for epsilon between 0 and 1, it's a gray body. Okay? So when you are very close to 1, this means that the gray body will behave like a black body. However, when you are very close to 0, this means that you don't have a radiation flux emitted by the surface. Okay? Now, sigma is a constant. It is called the Boltzmann constant, and it will be provided for you. A is the area of the surface, and T is the surface temperature. Now, whenever you have radiation, okay, you will need to calculate a net flux. Why? Because any surface will be exposed to fluxes that are coming from other surfaces. So this is called big G, or irradiation of flux. Now, this irradiation of flux will not be absorbed completely, because also we'll see that we can define coefficients that are called, first, the absorptivity alpha. So you have a certain coefficient of absorption. So what will be absorbed by the surface is alpha times G. You have a part that will be directly reflected. So let me erase a little bit here. Okay, you have a surface, you have an irradiation flux, G. Now, this flux will be divided into mainly three parts. A part that is reflected. So you have the first part is reflected. This is why we define the reflected fraction. So you have rho G is reflected. You have a part that is absorbed. The absorbed part is alpha times G. And you have what we call the transmitted part. So it will just go within the medium and go to the other side. It is called tau. So this is why we can say that alpha, tau, and rho are the fractions that will divide the G into three parts. This is why we say that rho plus alpha plus tau is 100%, or is equal to 1. Okay? Now, what we care for when we talk about the net flux of radiation is what is coming, what is absorbed by the material, and what is emitted in the space. So we can say that the portion absorbed is alpha G. Now, a part of this absorbed heat can be emitted back. Okay, so this is the emitted flux. The emitted flux E will be calculated as epsilon times sigma times T to the power 4. And when we multiply by, so this is in watt per meter square. When you multiply by the area, then you get what we call the radiation rate of transfer, which is in watt. So just to give you some notation, when we talk about heat rate, it's in watt. When you take about the flux, heat flux, it's in watt per meter square. Okay, so now what will happen is the following. To get a net balance of radiation, you take into consideration what is absorbed minus what is emitted. Okay, so this is why we say Q radiated net. So the net flux that will go out is equal to epsilon times area times sigma times T surface to the power 4 minus what was absorbed, which is alpha times G. Okay, and G, alpha G, so this is alpha times G. G also can be calculated as the area, if you want, of the surface times sigma times the temperature of surrounding T infinity to the power 4. When can we say that we can apply this formula? When the area of surrounding is much larger than the surface area. And for example, if you have the sky here, the area of sky is very large, okay? And you can consider that you have this area is at a temperature T infinity. When you want to find the exchange with this surface, you can find that G, which is the absorbed flux, can be expressed as the area of the surface of interest times sigma times T epsilon to the power 4, okay? And now, for majority of bodies that we know, we can consider that epsilon can be taken equal to alpha. So if you use this assumption, we call them opaque bodies. For opaque bodies, you can take alpha equal to epsilon. And then when you take epsilon A into factor, you have epsilon times A times sigma that can be taken into factor. You just still have T s to the power 4 minus T infinity to the power 4. This is how we calculate the net radiative flux for a surface. Okay, so we did a small review last time and now about the different processes of conduction, convection, radiation. Now we'll start to do some practical example. We'll start together by simple example first, then we'll move to more difficult ones. And after this session, please try to do the problems that I assigned for you on Moodle. Plus, you have also an assignment to make sure that you are familiar with equations and you are dealing with these problems in a good way. Before starting with problems, do you have any questions on the processes of conduction, convection, radiation? Okay. So let us start with problems. I prepared a set of problems to solve with you.
Professor, the problems هن ذاتهم موجودين على اليوتيوب videos؟
لا هول new one اللي عم نعملهم هلا are new problems, okay؟ اللي موجودين already in YouTube playlist. You can find them بالمودل. You have problem folder first, you have assignment folder second, and you have two parts, problems and assignment. And now I'm solving with you extra problems so you can profit from extra practice, because for other problems it's already solved before. Okay, and you have the videos. So please go over the videos, and each time during the live session we can discuss. If you have any difficulties in this problem, then we can solve new ones. Okay. Do you see the file or not yet?
Not yet, doctor.
Yeah, maybe it's taking some time to share it. Let me know when you see it, please. Okay. Okay, I will share again. Maybe there was a problem in changing from one screen to the other. Okay, I'm sorry for this, Yalla. 1 minute. It should work. Guys, do you see the file? It's still not showing. Look, I will exit and enter Zoom again. Okay, maybe it will be it will work. Okay, so I will stop this meeting and start a new one.